Hello everyone. So we have our first question here saying that two particles A and B of masses 0.4 kilograms, 0.2 respectively are connected by light in an extendable string. Okay. So it starts from rest and then it starts to move after it is being released. Now, for part 1, we want to find the motion of A before it reaches the ground. Show the magnitude of the acceleration. Each particle is 10 over 3 and find the tension. Now, let's focus on particle A. Before I move that, let's write down the possible forces here. We have weight, we have tension, yeah. Okay, now we can move on. Now acceleration is going to go down here because of A is heavier than B. Okay, all right, so now focusing on particle A, F is equals to ma. The possible forces here are W is going to be positive because it's in the same direction as acceleration, minus tension is equals to ma. So weight of particle A is going to be 4 minus T is equals to 0.4 A. Let's call this equation number 1. For particle B, we have tension. Tension is positive because it's moving in the same direction as acceleration. W is negative, then we have ma. We don't know tension. We do know the weight, which is 2, and then 0.2 A. Equation number 2. Okay, now let's start with the simultaneous equation. I'm going to use the first equation, making T as a subject. We are going to get T equals to 4 minus 0.4 A. Then I will insert this into the second equation. We'll have 4 minus 0.4 A minus 2 equals to 0.2 A. Then we'll have 0.6A is equals to 2, and then A is equals to 10 over 3 meter per squared second. Found. Next part, you want to find tension. So tension is equals to 4 minus 0.4 to the bracket of 10 over 3, and then tension is equals to 2.67 Newton. Okay, so these are two things that you need to find. All right, great. So let's move on to part 2. So part 2, we want to find the maximum height of B above ground. So let's remove all of this. Above ground. So when A travels all the way down and A is currently at the ground, this is A, B has traveled 0.5 meters up, right? 0.5 meters up. So now this is going to be the new position for B. But do take note that when A is at the ground, B is after that motion, B is no longer tied to A because A is now at rest. B is going to keep going up until it reaches at a certain maximum point, which in this case, in this motion, it will be in a free fall motion. Okay, but let's first find the velocity here. The final velocity is going to be initial velocity for the next phase. So let's use the constant acceleration formula. So we are going to use v squared is equals to u squared plus 2as. Now we're going to find v. Our initial acceleration is 0 because it starts from rest. 2, we have acceleration is 10 over 3, and the distance traveled is 0.5 meter. Okay, so now v, I'm going to straight away find it, and it should be equals to root of 30 over 3. Okay, I would leave this in exact form because I don't want to contaminate my final answer. All right, so this is our first step. Our second step, now we've already found the v, which is going to be this. So that's going to be the initial velocity for the next motion, the free fall motion. Now for the free fall motion, we know that when it reaches at the maximum point, our velocity is equals to 0. Now what we need to do is we actually need to find the distance between these two motions. Okay, so we are going to use the same formula. V squared is equals to u squared plus 2as, right? Now our v is going to be 0 because it's at the maximum point. Initial velocity is going to be square root of 30 over 3 plus 2. Acceleration is going to be negative 10 because it's gravity is pulling it down. Now and then s, right? We want to make s as a subject. That's what we're going to try and find. So we're going to have 20s. When I brought the 2 times 10, 20, bring it to the other side, becomes positive root of 30 over 3. And then s is going to be equals to 0.0913 meters. Okay, but this is not the final answer, it's just a little bit of distance there. Now, questions asking for the maximum height of B above ground. Okay, so initially B is already 0.5 meters above ground. After A is traveled down for 0.5 meters, B travels up for another 0.5 meters. But B doesn't stop after 0.5 meters, after the additional 0.5 meters. So B is going to go in a free fall motion just for a bit, and that is where we want to find our extra maximum height. Okay, so the formula for the last part here is just going to be 0.5, which was the initial height, plus 0.5 of how much the B traveled in relation to A, then plus 0.0913 for the free fall motion. So we add all of these up and we should get 1.0913 meter, and that is the maximum height that B can achieve above ground. Right, I think I made a mistake here. I found that I didn't square this, right? Okay, let me square this one, and you should get a new displacement. Then you should get S equals to 1/6 meters. Okay, so this is a slight mistake here, 1/6. Then you should get around 7/6 meter, which is equals to 1.17 meters. Okay,